You're listening to Masonry Principles, your guide to building better buildings, with hosts Amanda Babaian and Phil Leden. Thanks for listening to Masonry Principles. Today we've got Peter Babaian with Simpson Gumpertz Heger. He is the principal out of their Chicago office, and we're going to discuss retrofitting and repairs of masonry buildings. How you doing, Peter?
Great, Amanda. Thank you for having me.
Thanks for coming. And we've got Phil on, and we're going to jump right into things.
Yeah, I think, I'm really excited about today's conversation. We did have Tina Sabasic on a long time ago talking about sustainability and Jason kind of talking about resiliency. And I think in terms of masonry, a lot of our buildings are kind of built to last a really long time. And people move out, people move back in. And one of the issues we deal with in Michigan or throughout much of the Midwest is, people move out of a masonry building, might be 100 years old, was designed for whatever energy codes there were in the early 1900s. And now we have a new tenant wants to come in, a new office, something like that. And the question always comes up about insulating the inside face of some of these existing buildings. And Peter, I guess, does your office or do you specifically have experience kind of with that?
I do. We have looked at that as a item for many owners who are looking to retrofit their existing masonry buildings. There were really no energy codes back in the early 1900s, and it was something where people were relying on the fact that a mass masonry wall absorbed heat throughout the day and kind of radiated that heat off during the colder portions at night, and vice versa would keep the heat out if it was summertime by taking a long time to heat up the wall, and then would heat the room at night or the interior at night as the summer temperatures cooled off at night. So it's a mass masonry wall principle that works well when the wall system is open and available to transmit that heat. And a side effect of that is it's also able to absorb vapor, absorb water, and release vapor and release water. So we have seen a lot of focus on trying to insulate these types of buildings, these masonry buildings that are either mass masonry construction or transitional masonry construction, but have essentially a solid masonry wall for its enclosure system. And there are many considerations that need to go into that, including the type of masonry, the properties of that masonry, the amount of insulation that's being provided, the ability of that insulation to allow for water vapor to pass through it if that's something that needs to happen. So there's a lot of considerations, and we have tools such as hydrothermal modeling, analysis tools like the program WUFI that allow us to make some of the assumptions that we need and to model these to understand how they're going to work. And then finally, many of the brick masonry buildings oftentimes were sourced with brick masonry close to the building itself, and oftentimes from masonry fabricators that no longer exist today. And it's important to understand what that masonry properties are of those brick or stone if it's got a stone layer as well. And the best way to do that is to sample the masonry and send it off to a lab for testing.
When do you get involved with it? I mean, if I'm an owner, I want to buy a building and move my staff in there, and would it be wise to, I guess, do some of this testing and preliminary work before we even purchase the building? Or do you see it typically happening, now that I've bought this building, want to comply with the energy code? Oh, shoot, now I have to, do all this. When does all that kind of happen?
Yeah, our experience is that it does not happen at the time of purchase. Most building transactions, the owner has a very limited time to close, and they can't get all of this assessment done at that time. Most of them are buying the building, turning to their design team for whatever renovation or retrofit is needed, and their design team are the ones that are starting to go into these deeper condition assessments, figuring out what can and can't be done and what the end result will be of the renovation and retrofit of the building. And many of these buildings are either historic or eligible for historic listing or may have other considerations to them that allow them to either have a variance from a local code official or to even not have to comply with certain energy code requirements based on the building itself and its value to the community and to the historical nature district that it may exist in.
Yeah, I don't have as much background with historic, I guess, buildings. So is that something that once it happens, then it, continues forever as long as that building's in existence, they never need to comply with an energy code, or how does that work?
Yeah, I won't say that they never need to comply. There's certainly a chance that energy codes or the building code will change in the future. But there are sections written into the code that allow for consideration of the historic nature of some of these buildings and what the impact would be of performing some of the retrofits needed to bring them up to current code standards. One way to look at it is energy. Another one to consider is structural upgrades. If you're making changes to the building, oftentimes you have to comply with a base wind load requirement, which may or may not be possible without substantial structural intervention. So the building codes have different exceptions and exemptions allowed under them for some of these, but they're pretty narrowly written, and it is something that not every building is going to qualify for because in the end we do want our buildings to be safe for the current loads that we are expecting for them to see within their lifetime.
Yeah, I guess that was one of my follow-up questions that you kind of answered, but I mean, especially with putting insulation on the inside of the wall, I know that can sometimes cause some dew point issues or condensation, and so yeah, I mean, are you solving, yeah, I guess one problem, but creating a myriad of other problems? And I mean, have you seen that happening with especially dew point and condensation?
Yeah, what we're really looking for when we insulate the backside of a masonry wall is are we going to take masonry that's maybe in the middle weights of that wall that may not be as good from a material property standpoint? Oftentimes it's more the common brick, the brick that was less well fired in the kiln. It's not really the exterior grade brick. And are we going to suddenly have more moisture absorption from rain events due to the inability of that wall to dry out as quickly because there's a loss of heat from the interior? And are we going to subject it to a deeper freeze thaw location within the wall system? So with the heat loss that would be occurring in the winter in a three wythe wall, that interior wythe of masonry may never actually reach freezing temperatures in the wintertime without insulation on the inside. But when you put insulation on the inside, now that middle wythe may reach freezing temperatures and it may not resist freeze thaw cycling as well as that exterior wythe does. So that's really the biggest issue that we're looking at when we are considering insulating the backside of these solid masonry walls.
Yeah, and obviously, I mean, that would apply to any of our freezing climates, for sure. And I know you had mentioned kind of some structural restoration as well, and we commonly see that, in Michigan, where I live, and throughout much of the Midwest, where we have these older masonry buildings. Someone wants to move in, and we have to do some of that structural work. And I know, a lot of our mortars historically have been a lot weaker than some of our modern cement type mortars. Is that something you're looking out for? Is that something a lot of people are aware of? Because I have seen cases where people have used too strong of a mortar and kind of some of the issues that causes. Do you still see that happening?
Yeah, we have seen this and we're seeing more awareness of it in the industry. The consideration of mortar for repointing or repair is often a topic because there is a concern that if you were to take a wall system that had a lime based mortar, a softer mortar, and replace it with a cement-based mortar, the strength that you're allowing into the wall system or imparting into the wall system is going to potentially cause issues with the way that the structural loads in that wall system behave. And we have had reports of things like the brick in locations adjacent to the mortar being spalling or popping, allegedly due to the stronger mortar. There is concern that a lime-based mortar will breathe more readily than a cement-based mortar. For the most part, unless we find that the brick is truly very soft or very weak, we find that a type N mortar can be put in many of these types of buildings. But when you do get to some of the weaker brick buildings, and some of the more historic constructions, there are many considerations for a type O or more of a lime-based mortar to be used in these situations in order to make sure we're not adversely affecting the masonry.
And in terms of mortar strength, and I know a lot of these buildings I've looked at, I think kind of the historic mindset was to basically make the wall wide enough or heavy enough that it resisted kind of any of that flexural tension. And so I don't know historically, I guess engineers were really concerned about flexural tensile capacity of mortar. Is that true, I guess, in your experience?
Yeah, most of these mass masonry buildings were built off of rules of thumb or empirical knowledge. Oftentimes they got very thick, very heavy at the base, and tapered as you went up. But it was always about making sure that there was essentially no flexural tension in the masonry and that everything was in compression. And that's one of the reasons why when we are in freeze thaw environments looking at a building, that we are paying special attention to headers between withes, because we want to make sure those headers are in good shape and not cracked, because we don't want to lose the resisting capacity of the full composite wall system against those wind loads.
Yeah, certainly. And, with all these remediation options, all these repair type options, I mean, you said a lot of times, and I definitely believe it, that owners, are put in a situation where they have to close now. But I mean, how, from a cost or planning perspective, I mean, are a lot of them moving more towards like a band-aid type fix, or are you seeing a lot of owners kind of taking a more long-term holistic approach? I mean, when you're buy a building, how do you really plan? Is that a service your firm offers? That you kind of put together a plan for the next 10 years of what you need to do. I guess I'm just kind of wondering how someone would know what they need to do and when.
Yeah, most owners, when they go to buy a building, do get a condition assessment done. And certainly they can hire a firm that does condition assessments and kind of has a specialty in house to do all aspects of the building. Oftentimes it's an architect led firm, and they're able to walk through and they can see a good amount and understand, oh, there is some masonry deterioration here, or the stairs aren't wide enough there, or egress will be an issue, or your mechanical systems are old, right? They have that bigger view of it. And those condition assessments usually provide the owner kind of a 10-year maintenance expectation moving forward in terms of costs. And I know that a lot of owners use that as a way to kind of negotiate fees. So it's just like buying a house, right? You have a home inspection. This is kind of the building inspection. And for the vast majority of people buying a building, if it's not too big of a building, they have a person or two people at a small firm that do that, do all the systems. When we get into some of the bigger buildings that might exchange hands, oftentimes it's a team of people performing that assessment. So you'll have somebody who's mechanical specific, enclosure specific, structural specific, etc. That's something that our firm does get involved with from time to time, and it helps give the owners a little bit more granularity as to what they might be experiencing in kind of the 10-year maintenance cycle, keeping the building as is. If an owner is intending to buy a building and do a significant retrofit, most owners I know are going to pull their architect team, or at least their architecture group that they work with often, through the building and ask what can be done, and start to get some ideas as to what the parameters of cost may be, whether that's a large rough order of magnitude number, or if it's a square footage cost that they should be budgeting if they were to buy the building. And then to get to your piece about kind of how different owners handle that, I think it depends on how long they want to own a building for. If it's a owner that is looking to do some type of freshening up of the building, and then flipping it, putting it on the market in a few years, they probably are not going to be making a bigger investment. If it's a owner that's going to plan on owning the building 20 to 50 years, they may decide to take the plunge and do it all at once, or they may come up with a way to phase the work that needs to be done over the course of a set period of years in order to make it more affordable for them. So we see it from multiple different viewpoints, as well as different approaches to the way that owners do this.
Yeah, that makes a ton of sense. And I mean, it sounds like, what you do, you kind of take that holistic approach, and it's really what we advocate for here. When we see issues, are we going to really treat symptoms, or are we going to treat kind of the cause of them? And I think, that kind of gets down into the cost, like you were just talking about, where sure, we might be able to fix some symptom that's relatively easy, but how do we really fix it for the future? And I mean, are you seeing, I guess, the industry doing things more short term, treating symptoms, or are you seeing them, doing a little more testing, a little more investigative work, and kind of getting to the causes of these issues?
Yeah, I would say that most of our clients are usually looking for the actual cause. They recognize the symptoms, they want to understand what's causing the symptoms. And then once they understand the cause and the implication of what that is from a cost schedule standpoint, then they make decisions as to whether or not they're going to treat a symptom or actually go after the cause. And again, that depends similarly to when you're buying a building as to what your plans are for that building. An owner that's going to own it for a long period of time will oftentimes want to treat the cause, whereas those with a much shorter horizon oftentimes are treating the symptoms only. So it really depends on the ownership, their cost structure for the building, and their time frame for holding the building.
Yeah, definitely. And I think, I mean, that deals with a lot of what we have in Michigan, because a lot of our older historic type buildings are three white kind of brick masonry buildings. Like Peter had said at the beginning, I mean, a lot of the clay masonry assemblies definitely were built, with local materials. And I think that we mostly see that in most of our larger cities. I mean, Chicago had to have been that way. Was that what you see in Chicago as well, Peter, with some of the historic brick masonry?
Yeah, absolutely. Chicago has Chicago Common Brick, locally produced, locally sourced. We see it in the other cities as well. Every major city had a brick fabricator, kiln operator, and we're churning out bricks because in the late 1800s into the early 1900s, this was really the type of construction, and all the way up through the transitional masonry era, where we had the structural frame being concrete or steel, but encasing it with a essentially a mass masonry wall system that sat on the spandrels integrally. That's where we see a lot of this masonry and a lot of the issues, and really where the expenses for doing the repairs as well as for bringing it up to code with energy requirements. So anything really past World War II for masonry, typically we're getting into some type of a cavity system. May not be the best produced cavity system if it's from the 50s and 60s and 70s, but it's a different animal altogether in terms of how you go about retrofitting, and the work that's done on it for problems. Even the symptoms and the causes are, in some cases, different than what you have on the transitional masonry and mass masonry buildings.
And I did have a question. So, I mean, I don't know if it's necessarily lore or if you know the answer, but I mean, there's a lot more masonry in Chicago, and I've often heard that was because of the fire, that happened in Chicago. Is that the case that their building codes were kind of changed back then to promote more non-combustible construction?
Yeah, Chicago definitely does not like to allow for fire to take hold in the city. Based on that fire, the Great Chicago Fire, there was a change in the building codes. There was a lot more non combustible construction. And some of those changes continue to this day in the sense that some more combustible materials are not allowed in the construction. For instance, something like eaves until recently has been limited to 40 feet on a building cladding system just because of the potential for combustibility and the desire of the city to not have very much combustible construction. That said, when we get into the single family and the small multifamily, two, three residences, there are some constructed out of masonry. There are some constructed out of wood. And I know that there's been some pushes for cross-laminated timber and other types of wood construction in the bigger office market in the 10 to 12-story range, but I'm not aware of any of those that have been able to get approval yet.
Man, well, working for the masonry industry, I would love to figure out what you guys have done in Chicago and kind of take it, especially as we see more and more wildfires increasing across the country, just educate people more on non-combustible construction.
Sadly, I think you need to have the city burned down in order to really move a building code that drastically to the non-combustible side. But unfortunately, that did happen for the city, and the legacy kind of remains.
Yeah, well, hopefully it doesn't come to that in other areas across the U.S. Well, I've covered mostly everything I want to cover. Amanda, is there anything you want to cover about historic or, masonry restoration?
No, I think that was great.
All right. Well, thank you very much, Peter, for being on today. And thank you to all of our listeners for listening into this episode of Masonry Principles.
Great. Thank you for having me. And if you don't mind, I'd like to mention that the Masonry Society is having a existing Masonry seminar series starting this October. It'll be about 7 lectures, one weekly, from October into December, and they'll be covering a lot of these topics in much more depth.
Awesome. Yeah, that's a great plug and yeah, a really good resource there. Thanks for bringing that up. Thank you to all of our listeners and have a great day.
Thank you for listening to this episode of Masonry Principles. To continue the conversation, be sure to reach out to us by visiting masonryprinciples.com.